Um,
I'm
Eagles. Redo.
sorry, were you offended by that?
No.
I don't even think you heard what I did you hear what I said?
And redos.
Yeah, I
See,
don't
he's
know what that
ignoring.
means.
I
I
think
don't know
so.
what that means.
Uh, you're such a party pooper.
Not a native English speaker, sorry.
Look, she was talking. She was naming birds, right? She said blue jays, robins, and I said and redos. I'm talking about your name. I was talking about you. I was saying you were a bird. Thank you for ruining the joke. I appreciate that.
Now it is funny.
Yeah, see, but not. Never mind.
So funny.
I'm done with you, dude. I've been trolling everybody, by the way.
You go,
I've been
girl.
like, I've been changing everyone's names all day long. It's so fun.
So
Cause
you're
I'm a
the
mod
one.
now.
Hold on. Did you change TikTok's name on that other server? Because he was pretty angry. So,
Oh
so you're
really?
the one. So you're the one who changed it.
No, I think that
Yes.
was. I think was it you?
No, it was me.
Was it?
I put TikTok on the clock. Why did he get mad? It wasn't like I
Okay,
changed
so
something
I'll
crazy.
tell him. I'll
You
tell
did
him
it for me. I
pumpkin.
didn't get
Yeah,
mad at you.
tell him so he won't be upset. I'm sorry.
Yeah, you
So
see
fucking
what
pissed now.
happened the day before when Sheeple was doing random stuff. So he changed all the Globers' names, and yeah, he then came to us and he said, "Oh, guys, listen, it's just a joke." But TikTok got like really pissed about it.
My
We
name.
there is the new server, and boom, TikTok's name is changed again.
Okay, so
I feel so bad. I had no idea. Like if you see him, please tell him it was me and I was just playing around. I was abusing my power as mod.
so before 2.0 was created, what, yesterday or whatever, or maybe it was the day before, I was in the voice chat and then I looked down and I noticed my name was changed and it said One Hot Mama. I'm like, you bitches. And I just I didn't say anything. I just changed it myself. Because that's like an old thing sheeple used to do all the time. And so,
Oh,
yeah.
hot mama.
One Hot Mama. Yeah, it's like, screw you guys. Like, shut up. So,
That's kind.
yeah.
That's kind of cute actually, but I can see how that'd be annoying after a while.
Okay, I just want to make everybody aware right now we are live. So.
Oh, thank you.
Mhm.
So, yeah, for
um.
me, not a big deal. Easy fix. It's like, you don't need to whine and complain about it for 10, 15 minutes. Just fucking change it.
Yeah. But yeah, today was interesting. We were just discussing different topics, going over Right now, I think they're talking about gravity. Like, I don't think I've ever, as long as I've been here, I don't think a day has ever gone by where we've not talked about gravity whatsoever. So it's like they're just going over that and arguing about that and stuff.
Pumpkin, you're probably way, way more knowledgeable about me on the topic of gravity. So, isn't the formula for gravity like oddly similar to a different formula for a different quote unquote force? And I can't remember what it was right offhand. I just remember it being talked about at one point.
That's one thing I actually don't
Force.
know.
Do
The
you
force of
possibly refer to Coulomb's force?
Yes. Okay. Yeah, that's it. Yeah. Coulomb's law, right? So, is that what is Coulomb's law? I mean, I could look it up, but like a
Well,
layman's
it's pretty
explanation.
simple. One of them is about mass attracting mass, and the other one is about electric charge attracting electric charge. So yeah, they look similar. But
Yeah,
the
well,
one
like
with mass attracting mass, well, that's the Newtonian one. Like, it's not the way people think about gravity
Right.
anymore.
Right, exactly. Like my whole thing, my position on gravity is the whole like what annoys me about the entire argument is that they constantly use Newton's equation. Talking about force equals mass times acceleration. Not the reason why it's frustrating is because they don't understand that when you're applying a force on an object, like it doesn't matter whether it's pushing or pulling or anything like that. The point is that once that object is being put into motion, whatever put that object into motion, that was the force that caused it to move. But they'll completely ignore that part and they'll just say, well, something has to keep making it fall down. And it's like, no, you released it. It was sitting at rest when it was on the
So
table.
this is the
And
first
then as soon as
law
you
of Newton. This is the first law, like. So they, who says that?
you do understand what I'm saying, right?
Right. The first law says if you put something in motion, it stays in motion unless acted upon by another.
Right, and that other force would be once it hits the ground, that upward force of the ground stopping the object from falling. But the problem is that they'll take that and they'll take that to say that, oh well, because you need a force for acceleration, gravity's the one that's causing the force. And like that's the thing, but gravity didn't make the object move out of its position. Like whatever knocked it off of balance, which could be you, or it could be like an earthquake knocked something off of a table or a mountain or whatever. Like it was no longer in equilibrium. That's what's causing it, and due to its own mass, it starts to accelerate towards the ground. So like the whole idea that that you need some type of continuous force constantly acting on the object doesn't really make sense to me. When the only evidence that you observe in that effect is the object due to its own mass, due to its own properties, what is contained in that matter is going to cause it to fall down at a certain rate. And because it's I don't understand that. I don't understand why they don't consider something acting on the object a force. It doesn't say specifically what that force has to be. It just says that force equals mass times acceleration. The object accelerating towards the ground. That's it. Once it's so it can be anything. Anything can cause that force to happen. So it's that's just my opinion. I don't. People could probably disagree with that, but that's how I feel about it. I feel like it becomes way more complicated when you assume that there's some type of pushing or pulling force. It becomes way more complicated.
Oh, I don't think there is an easy explanation, but if you want to clarify your own understanding of like the Newtonian explanation of gravity or Einsteinian, I suppose you would have to look into these specific topics and read up on that.
Well, that's the thing. Like those two, though, like Newton's was abandoned, and even Einstein's is about to be rewritten. They're actually considering throwing that out as well at this moment.
I know.
So it's that. So it's not even, huh?
I know that Einstein's is like recently there was a news article that they have already are sure that Einstein's is not like this final explanation.
Right, but that's because that's the thing. You have to understand where Einstein was starting from and where Newton was starting from. All of their assumptions start from assuming what the Earth is and assuming what is causing the planets to move. They're assuming those two things that they have not verified whatsoever, and inputting them into their equation, extrapolating and then
Yeah.
trying to attribute cause to them. That's the problem with this entire theory of gravity, is that they're going based off of their own assumptions as to what is occurring to make their conclusion. And that's
Yes, you've already said that you don't like assumptions, but that's not how people do things.
oh, I'm sorry, what?
You already said that you don't like to start with a lot of assumptions, but that's how we do things sometimes.
No, that's
For
not. But that's
example,
not the right. But that's not the right way to. But that's not the right way to do something. If you're trying to create a theory, like you don't just start off with an assumption and then build things off of that assumption. You try to verify that your assumption is correct. If you assume something,
well,
that's fine. Start off with an assumption and then verify whether or not that assumption is correct that you made. You can't just be like, oh,
the
let's
fine
assume
print.
this and then try. that's my point. So you're saying, well, you don't like assumptions. Like I would appreciate it if you not paint it that way, because that's not what I'm saying. I don't think that it's
Yeah,
appropriate for anybody to be
I
starting off
should have
with an
been more
assumption.
clear. The fine print is that the assumptions that you make in your theory, which you make, it will still have to boil down to testable consequences, testable mathematical consequences that you can test, observe, check. You can't just assume things
No,
that don't have any, consequences that are untestable. That's the fine print of that.
well, not necessarily. Like that's not even what I'm saying. In that instance, I'm saying that if you assume that the Earth is a sphere, if you're assuming that, starting off with that assumption, like for example, I can assume that somebody's house is 37 miles away, and then make an entire extrapolation from that. But then I
And
thought,
then you check.
but then I didn't actually verify whether or not their house was 37
You
miles
have
away.
to. You have to
So
verify it.
that's my
You have to
point.
verify it, or you're not doing science. That's the rule. If you make an assumption, if you then make a mathematical formula from that assumption, the final step is verification. If you verify it, it works. If it doesn't work, you put it in the trash can and move to the next one.
Well,
Actually,
you're saying if you verify, why wouldn't you start off with verification? Why wouldn't you start off with verifying it first? You're saying verification comes after,
because
which
you might
that's
not have all the data. This is to work around all the parts that you don't know. For
so why not
example,
get the data first instead of assuming that the Earth is a sphere? Why not figure out whether or not it is a sphere, and then work from there, and then work from that point?
um,
It
because you can
isn't.
still work without it. Like,
No, you can't. No, you cannot. That's the point. That's the problem.
why?
If you're already assuming, hey,
Why? I mean, in quantum physics, there is a gazillion assumptions. Like the assumptions that regular ones make. It
Hi.
is, there are very few assumptions made by Newton or Einstein when you compare it to quantum mechanics.
I'm
So,
sorry, I'm back. What were you saying?
so
I had
okay.
to go for a second.
You said that you should start not with assumptions, but with something that is measurable, right?
What I'm saying is that like if you're going to start off with the assumption, verify your assumption to be correct first. Like if you're talking about an object being a certain way, like now if you're talking about the cause of something, that's different. Assuming the cause of something is like, which is what you're really doing in science, an actual scientific. The scientific method is about cause and effect. Like you observe a natural phenomenon, and you're trying to figure out what is causing that effect. That's when you will be working off of assumptions, because you don't have the data, or you don't know what's causing the effect. However, with the Earth, that's something, starting off with assuming that the Earth is a sphere would be the incorrect way to go about a scientific experiment, because you're talking about a physical object, not a cause and effect relationship, not a cause and effect
I
not a
don't
cause and
think
effect problem.
it's strictly about cause of and effect like you describe.
Well, like if you're talking about the scientific method, which the steps in the scientific method do require cause and effect thing. Oh, I'm sorry. Hold on a second.
How ready are you?
Um,
Uh,
crap. No, the yellow jacket kept. Someone's like literally following me.
I'm going to follow you.
Huh?
I'm going to follow you.
Okay.
Hello.
Okay, I'm back. I don't know what the
Hello,
heck
hello.
happened. Okay. So what happened? So what was I saying? Yeah, like
You
you were
were
saying
talking
that.
about assumptions.
Yeah, you were saying that you don't think that it's just based on cause and effect, but the scientific method that I'm speaking on, I know that you said that you were taught a different type of method, but the method that I was taught is absolutely 100% about cause and effect. You observe a natural phenomenon and you form your hypothesis. Like you form your hypothesis, like if, like basically if I apply this, which would be, and what you apply would be your independent variable, which is what you will vary and manipulate in the experiment. That will be the cause, your presumed cause. You assume a cause first as to what is causing the phenomenon. And then your
Then,
dependent variable is the phenomenon itself. And your control variables are what basically what does not change in the experiment. For example, time could be a controlled variable in your experiment, along with trying to think of
Yes,
another
but
example, but
controlled variables, these are all concepts which we use when we're talking about experiments.
yes,
Scientific
I'm talking,
method
yes.
is way more general than that. It's
Mm.
scientific method is not a handbook how to do an experiment. It's a general explanation how you should
There is
work.
no scientific method without experiment. So
Well,
what I'm
obviously it's
describing,
part of it, but it really doesn't go into that.
indeed that thing, because you can make a bunch of basically a bunch of mathematical assumptions. Hence why, like, think about it this way: the fact that the distance of the sun was constantly changed to scale. Like the distance of the sun wasn't always 93 million miles away. Like they were like, even though they had already had the idea that Earth was a sphere and everything like that, they were constantly
I
trying to change
know,
the scale of the. I'm sorry.
I know that the value changed across history as we got more information.
What information?
Well, the more advanced measurements. I think the first ones
What
were
measurements?
basically just the telescopes of the like ancient Greeks. I think or Chinese. I think they had like simple measure that they